Okay, guys, so just as a reminder, law of cosines, you have, law of cosines has to do with either knowing two side lengths. So say this is 8 and this is 13, and then you know the angle 41 degrees, right? So if you know this, and you know this length, and you know this included angle, then you can use the law of cosines to find the other side length and the other two sides. Well, in fact, it helps you find this, and then you can go from there, okay? It's also good if you don't know this, so say you don't know the angle, and you do know a third side. So say this was 9. Then, well, that's 9 point something, right? And then, oh, I guess I could just make it 9 and then whatever the angles are. They are. You can use law of cosines to find any one of these angles and then go from there. Okay? So, just a reminder, you've got side A squared equals side B squared plus side C squared minus 2 times side B times side C times the cosine of the angle A. So this is where you got B, C, BC, and then the included angle A. Okay, and that is the way for you to solve for side A. All right. This is true also if you just rearrange it. If this is angle B that we were trying to solve for, that would be side B and A and C. So B squared equals A squared plus C squared minus 2 AC cosine of angle B. And then if this is C squared, then this is A squared, B squared, A, B, and then C, so angle C. All right. Let's also talk about solving for the angle. If you've got A squared equals B squared plus C squared minus 2BC cosine of angle A, and you're trying to solve for angle A. So what you need to do is you need to subtract the B squared over, subtract the C squared over. So that gets rid of those two. And then you're trying to solve for A. Right now you're multiplying by negative 2BC. And then you're taking cosine of A, right? Which is why these have to be taken care of separately. So you would divide by negative 2BC.
You got the face in?
Which gets rid of that. And then in order to solve for A, you're going to take the cosine inverse, which is the inverse operation of cosine. And that is angle A. All right, now one thing you do need to be careful about is when you're typing in these numbers. So say you type in 15 squared minus 6 squared minus 12 squared, right? Okay, a lot of times what you do, people will type in the calculator, divided by negative 2 times, and then they'll say 6 times 12. But the problem is that in typing this out, you only divide it by negative 2, and then you're saying, hey, multiply your answer by 6 and 12. So 45 divided by negative 2 times 6 times 12 is not that. 45 divided by negative 2 times 6 times 12 is that, okay? Cosine inverse of negative 1,620 does not exist, but cosine inverse of this does. So, what we're going to do, or just a reminder. Now, you could also do the alpha y equals and do this, and then just say the 45 divided by, not divided by, you got divided by, negative 2 times 6 times 12. And that would be another way to do it. Okay. And then if you need decimal. Really? I guess I need to go down there. Okay. All right. So let's start working the problem. Solve triangle ABC given that B equals 12, C equals 7, and A equals 55 degrees. So I've got a 55-degree angle, so I'll just go ahead and draw that somewhere in there. And that's angle A. I know side B is 12 and side C is 7, so I'll go ahead and make this B equals 12 and this C equals 7. And we need to find everything else. So I need to find angle B, I need to find angle C, and I need to find side A. So angle B, angle C, and side A. All right. Well, you do have a side angle side. You don't have an angle and a side pair, which means you can't use law of sines right now. But I can solve for side A using law of cosines. So I know A squared equals B squared plus C squared minus 2 times B times C times the cosine of the included angle, 55. And if I'm trying to solve for A, then I just take the square root of all that. So we type it in. Oh, keeps twisting. Okay. So the square root of 144 plus 49 minus 2 times 12 times 7 times the cosine of 55. So A is 9.831 if we round. Okay? 9.831. Now we need to solve for the other two angles, right? In fact, it's up to you. You can use law of cosines again to solve for angle B. But I'd rather just go ahead and use law of sines, because I can, because now I've got an angle and a side pair. So if I'm trying to solve for angle B, then I'm going to put sine of B over 12 equals sine of 55 over 9.831. And we're going to just multiply by 12. So we're going to multiply by 12, and then we're going to take the sine inverse of both sides. So sine inverse of all that. So in my calculator, I'm going to type in second sine inverse of 12 times sine of 55 divided by 9.831. And there we go. So we get the angle B is 89.1 degrees. Which makes sense as it has the largest side across from it, right? Now I need a third angle, and if I know two of them, I can just say 180 minus. So 180 minus 89.1 minus 55, and you get 35.9. So this is 35.9 degrees. And there we go. Okay. Let's this one. Solve triangle ABC given that A is 10, B is 7, and C equals 5. Okay. So we have a triangle drawn, and I've got to figure out the side lengths. So I just went ahead and drew a triangle on there for you, but as long as you just drew any triangle, it would be fine. You just have to remember that, across from the largest side, you get the largest angle, right? So 10, 5, 7, A is 10, so that makes that angle A. B is 7, which makes that angle B, and C is 5, which makes that angle C. All right. We can choose whichever angle that we want to solve for. Doesn't really matter. Although, no, yeah, you're good. I'll go ahead and solve for angle A first. So I know that, and I'm going to set up the law of cosines normally. Okay, so in its original. So I know A squared, which is 10 squared, equals B squared. 49, but I'll go right. Equals B squared plus C squared minus 2 times B times C times the cosine of angle A. And so if I'm trying to solve for angle A, it's okay. Oh, okay, sorry. So 100 minus, can someone shut the door and lock it? I don't think it's locked. Subtract 49, subtract 25, divided by negative 2 times 7 times 5. Subtract, divide, and then take the cosine inverse. And that is angle A. Hey guys, since we have a very short period, I'm going to go ahead, I'm just making a video of the lesson. If you get out your notes from law of cosines, you can probably go ahead and look at what we have as far as working it. But otherwise, you can just hang out and watch the video later if you need to, okay? But Heron's formula area, I'll talk about in the video, so you will need to watch that even if you feel like you're okay on law of cosines, okay? Talk to each other, see about what you would do to work it out. Yeah, that's not what I said. Okay, so cosine inverse, and I'll go ahead and do the, oops, no, just kidding. alpha y equals, and inside I'm going to type in 100. Oh, you can't even see it. So cosine inverse of 100 minus 49 minus 25 divided by negative 2 times 7 times 5. And I get the angle A is 111.8 degrees. Okay. So from here on out, I've got an angle on the side here. So if you want to, you can keep using law of cosines and solve for another angle, or you can use law of sines. Doesn't really matter. I'll go ahead and use law of sines. So I'm going to solve for angle B. So I know sine of B over 7 equals sine of 111.8 degrees divided by 10. So then I'm going to multiply by 7 and take the sine inverse. So sine inverse of 7 times sine of 111.8 plus parentheses divided by 10. And I get the angle B is 40.5 degrees. So if angle B is 40.5 degrees, then I can find angle C by just subtracting from 180. So 180 minus 40.5 minus 111.8, and you get 27.7 degrees. Okay? So all the things that I need to find, solve triangle ABC, I need angle A, angle B, and angle C. Angle A, 111.8 degrees. Angle B, 40.5 degrees, and angle C, 27.7 degrees. All right. Solve triangle ABC given that A is 1, B is 5, and C is 4. Okay. So if I were to just draw a triangle, we have a definite short side. So on one side is shorter than the other, 5 versus 4, and then 1, right? 5, 4, and 1. If A is 1, then that makes this angle A. If B is 5, then that makes this angle B. And if C is 4, then that makes that angle C. All right, so B, C, and A. Did you find it?
Yes.
Okay. All right, so whenever I am trying to solve using law of cosines, I'm just going to pick an angle to solve for. We can go ahead and solve for angle B. So B squared equals, just kidding, 5 squared. And if you already know what you're going to do to solve for the angle, you can just fill it out that way. So 25. So B squared equals A squared plus C squared minus minus 2 times A times C times the cosine of angle B. Yeah? So if I were to work this out, I would say B squared minus A squared minus C squared divided by negative 2 times A times C, and take the cosine inverse. Now what's going to happen on here, second cosine inverse of alpha equals 25 minus 1 minus 16 divided by negative 2 times 1 times 16, and you get you get 104. Sorry, give me a second. It's interesting that it even worked out. I wasn't expecting that. The reason why I wasn't expecting it is because if we look at these side lengths, 1 and 4 add up to 5, and in fact this would, if I tried to make a triangle, it would just collapse and create just a line. I'm kind of curious as to why this worked, but I will, I don't know, I guess I'll keep going and see what happens. So if it says that angle B is 104.5 degrees. I wonder if log sines would figure it out. So I then have an angle and a side pair. So if I solve for angle A, sine of A over 1 equals sine of 104.5 over 5. B. So we're using this angle side pair. So multiply by 1, take the sine inverse, or just take the sine inverse of sine of 104.5 divided by 5. Interesting. Oh, okay. I'm not gonna lie, that's okay. So 11.12 degrees is what it's saying for this one. So, okay. 180 minus 11.2 minus 104.5 is 64.3 degrees. So I'm just curious. Okay, if I do sine of C over 4 equals sine of 104.5 over 5. Let me work that out. Sine inverse of 4 times sine of 104.5 divided by 5. You get 50.76, which is not the same thing as that. Interesting. I don't know that you would know to check for that. I'll have to look into that as to why that didn't work out. I mean, I know why it shouldn't work out, but because I know you guys probably wouldn't think to check that. Oh my goodness. I bet it's right here. This gets ridiculous. 25 minus 1 minus 16 over negative 2 times 1 times 4. It says 180. That's what I was expecting from the beginning. But I couldn't find my mistake. Okay. So 180, which makes sense. Because if this side length is 4 and this side length is 1, then this is just a straight line against that 5, making that a 180 degree angle. Which means the other angles in the triangle are 0. Or you could say non-triangle. That's ridiculous. Okay. Right. Give me a second. If you do want to go ahead and take notes over it, I'm going to talk about Heron's formula. If you just want to go ahead and take the notes over right now. So Heron's formula, area of a triangle.
Is this going to be on the video?
Yeah. I'm just saying if you want to go ahead and do it right now so you don't have to watch that portion of the video later. So on Heron's formula, area of a triangle. Area, this is if you don't have the height. Because we know the area formula for a triangle, 1/2 base times height. But if you don't know the height of the triangle, you can always use this formula right here. And I'll talk about using both formulas in a minute. But area equals the square root of S times S minus A times S minus B times S minus C, where S is 1/2 the perimeter of the triangle. So if I have a triangle with side A, B, and C, and that means S equals 1/2 the perimeter. And what's perimeter? A plus B plus C, just the addition of all the sides. So you might want to write down this as well. So I would write down the area formula, and then also that S equals 1/2 A plus B plus C. Okay. Do we have that written down? I could pause. Okay. So for this case, it says find the area of the following triangle. So if you want to, go ahead and draw a triangle similar to that. So we've got angle A. So you got this obtuse angle right here. Angle B is 25 degrees. Side CB or side A is 12, and AB is 15. Okay, so if I actually wanted to use the area formula that we know, 1/2 base times height, I could actually do that. Where would the height be? You guys know where the height would be? Kind of depends on how you orient the graph, right? But if I let this be the base, then I could say the height is right here. Yeah? So if I let that be the height, 1/2 base times height. What's the base? 15. So 1/2, 15. And then what's the height? So in doing law of sines, we found the height quite a few times, right? So height equals what? Or actually, let's just set up the trig ratio and then we'll find height. So what is it? Sine of 25 equals height over what? Over 12? So then I could say that height equals 12 times sine of 25. And so height is 5.0714. I'm just using a few decimals to make sure. Okay, so in fact the area is 1/2 or 0.5 times 15 times 5.0714. And I get 38.036 square units, right? Because we're finding area, so whatever the units are. Are y'all okay with that? 1/2 base times height? The only thing I needed was to find the height, and so there we go. Now, the process that we're about to do is going to take a whole lot longer, but that's because I wouldn't need to use Heron's formula in this case, all right? Heron's formula is most useful whenever you just know the 3 side lengths and you don't know an angle, okay? But I do want to show you that it's the same thing. All right, so what's Heron's formula? The square root of s times s minus a times s minus b times s minus c. And what is s? 1/2 the perimeter, right? So do I know all the side lengths? I don't know all the side lengths, do I? I know A is 12. I don't know B, but I do know that C is 15. Yeah? So again, this is why Heron's formula, this one is not as cute. But I can find this side length. How? Using the law of cosines. Okay? So law of cosines says that if I'm trying to solve for angle B, or side B, do you remember the formula? We have B squared equals A squared plus what? C squared minus 2 times A times C times cosine of angle B. So this is where I know A, I know C, and I know angle B. So that's why these 3 are the things that are in the equation, because those are the 3 things I know. I know 2 sides and the included angle. How do I solve for B? I just take the square root of all that, right? So let's fill it in. B equals the square root of what? $144 plus 225. Isn't 15 squared 225? Minus 2 times 12 times 15 times the cosine of what? 25. So if I'm trying to solve for b, I just fill in all that information into that law of cosines. Cole, really? So I've got the square root of 144 plus 225 minus 2 times 12 times 15 times the cosine of 25. So I get that side B is 6.53675. I'm going to go ahead and write down quite a few because I want to make sure that I'm as close to accurate as possible. 6.536757. Okay? All right, so now can I find S? S equals 1/2 12 plus 6.536757 plus 15. And I'll just type that in. Go ahead and type it in so you have it in your calculator for whenever we do all these numbers. So 0.5 times 12 plus 6.536757 plus 15. And I get that S equals 16.76838. We'll go ahead and just round to 5. So S equals 17.76838. Okay, so what is Heron's formula? The square root. I'm going to zoom out a little bit. So that says area equals the square root of what? S. So that number right there, right? So 16.76838, I'm going to... Oh, I'm just trying to prove to you that you're going to get this. Just follow along with me because... well, actually, I mean, you can just go grab things up in the calculator, right? But when you use Heron's formula, which is when it's intended, like this right here, where I just give you 3 side lanes, it's really simple.
Caitlin
Okay.
Freeman and Haley Meisner are needed in the STEM Center entrance to board the bus for the field trip. Once again, by the STEM Center entrance. Thank you.
So then it's that same number, right? Minus what? A, which is 12, and it's that same number minus what? B, which is that longer decimal, 6.5367, blah, blah, and then times that same number, what? Minus 15? Okay, I'm going to do all of that in the calculator. Just go up and grab things as I need them, because, guys, isn't this B right here, and isn't that S? So I'm just going to go up and grab things as I need them, okay? So the first thing I do is S times, now what do I do? So S minus A, which is 12, close parentheses, open them again, go up and grab that S minus B, which is this up here, close parentheses, times, and then go up and grab S one more time, minus 15. There it is. Hey, actually that happens to me a lot when I make videos. Does it ever go blank for you, or is the video still recording? Oh, it never goes, okay. Wow. I think it's just my screen goes blank, but it's still recording. But anyway. Okay, I press enter and I get what? 38.036. And isn't that what we got before? Okay. So like I said, that was very ugly as far as like how much you're typing in, all the numbers, the decimals that you're going to have to do in order to get the accurate answer. I wanted to prove to you that you get the same thing as 1/2 base times height, okay? But that's not the most efficient way to solve it when you have an angle. Because when you have an angle, you can just go ahead and do or trig ratio, find the height, carry on, right? So on your homework, am I going to require you to use Heron's formula?
No.
Not if it's not efficient, okay? This is when it's efficient. Find the area of a triangle with sides 13, 15, and 18. So write down Write down A equals 13, B equals 15, and C equals 18. A equals 13, B equals 15, and C equals 18. All right. Now, could I, do 1/2 base times height? I could if I found an angle, but I don't need to. That's not the most efficient. In this case, Heron's formula is the most efficient. So what is S in this case? 1/2 what? 13 plus 15 plus 18? So that's 30, 46? Is it 46? So it's 1/2 times 46, which is what? 23? So Heron's formula says the area is what? S times S minus A times S minus B times S minus C. So when you're given 3 side lengths, that's a pretty simple formula to fill. So we just type it in and do, sorry, the square root of 23 times, and if you just want to go ahead and subtract, you can, times 8 times 5. And you get 95.917 units squared. Okay. I do want to say right quick. Earlier in the video, I did this problem, and I made a mistake in filling out the law of cosines, and so that everything was wrong, and I was confused about why, because I knew it was supposed to not work out, but then my numbers were messed up. So I want you guys to look at that. Look at that triangle. Would you look at that and know that there's an issue? I want you to look at the side lengths. Why is there an issue? 4 plus 1 is 5. So would I be able to form a triangle with 2 side lengths that equal the third side length? What would they do? They would just collapse onto that line, right? Meaning, what is this angle right here? 180 degrees, which is why when I worked it out correctly, first I accidentally put a 16 right there, and I was getting an angle, and I was really confused. I was like, man, and everything didn't end up working out, but I was confused about like how you're supposed to know from the beginning, because I thought it would work out. At the beginning you would know, and you do know because it says 180 degrees. So that's not a triangle, okay? Or at least it's not a triangle with any area. It's a triangle with one angle 180 and 2 0-degree angles, okay? But anyway, that's basically law of cosines and Heron's formula.